You remember the pattern?
Wait, question on a plus b cubed. Why is it not b cubed? Why is it b squared instead of b cubed?
Because I miswrote.
Okay.
Thank you.
I first said b squared and then I corrected myself.
I got it from you, okay?
So a to the fourth
A to the fourth, all right. Good with that one.
plus 4 a to the third, b. And then 4,
Not 4.
3.
We're just doing random numbers now? That's not 3.
It's not 4.
No, it's 6.
What?
Oh,
All right.
that makes sense.
Oh, plus 4ab cubed. Gotcha.
Right. Now at this point, if you look at the letter part of it, the variable part, it goes a cubed, a squared b, a b squared, b cubed. The next one would be a to the fifth, a to the fourth, b plus, and then that's a to the fourth, a to the third, b squared, a squared, b cubed, and so on. So the exponent of the first one decreases, and the exponent of the other one increases. The coefficients is the key right now. What are the coefficients for to the fifth power?
Would it be 5 and 10?
It would be 1, 5, 10, 10, 5, 1. What's the pattern? Or you just did to the fifth power in your head. That's what you got.
You get a new coefficient, like you get an extra factor each time.
Right. How did you know it was 10?
Because when we did before, when you said 6, I figured you multiplied.
All right. I was hoping some of this would ring a bell. I dragged it on probably a little longer than I should have. Pascal's triangle, does that ring a bell with anyone?
Yes.
1, 1, 1, 1, 2, 1, 1, 3, 3, 1. You just add the two numbers right above it. So that'd be 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. The first coefficient is always 1. The second coefficient is just whatever the exponent is. So like to the first power, it's a 1, to the 1, second power, third power, fourth power, fifth power, sixth power. So now back over here, I have 1 plus s over 2r. If the distance between my two opposite charges here, so if s is much less than the distance to r, so we are a particular distance away. Or actually we can 2r since that's what we have right there. Then 1 plus s over 2r squared is going to be equal to 1, because that's the coefficient, we're doing the squared one, times 1 squared plus 2 s over 2r times 1 plus 1 times s over 2r squared. If I did cubed, there's the pattern over there. A is equal to 1 and b is equal to s over 2r. If s is much smaller than 2r, then this is incredibly tiny. If this is 0.1, this is 0.01. This last term here, matter of fact, this term, whenever the second term is squared or cubed or whatever, if that fraction is small, then these become insignificant. So I'm just going to ignore that. It's not equal anymore when I get rid of it, it's approximate. We can generalize it as in 1 plus alpha to the nth power is approximately equal to 1 plus n times alpha if alpha is much less than 1. N is just, again, the exponent that you have right there. And the second term of the binomial is just raised to the first power, so we have n alpha. Now in this particular case, I've got 1 plus s over 2r squared in the denominator. In other words, that's times that to the negative 2 if I bring it up top. So this is approximately equal to 1 plus negative 2 times s over 2r, which is 1 minus s over r. It's a decent approximation. This is known as, see, that's binomial expansion. I used the term before, binomial approximation. That doesn't quite sound right, but we'll go with that for right now. This other term, when I bring it up top, that's 1 minus s over 2r to the negative second power, is approximately equal to 1 plus s over r. So my electric field at point P is KEQ over r squared. I'm just going to factor that out because both terms have it. Times 1 minus s over r plus 1 plus s over r. So it's approximately KEQ over r squared times 2. I lost something here. Hold on just a second. Oh, minus. That was my mistake. Try that again. So the ones cancel out, and I'm left with negative 2 KEQ s over r cubed. There we go. Q is we're assuming is a positive number. S is a positive number, that's a distance. R is a positive number because it's just the distance. K is a positive number, it's a constant. So my electric field does indeed point in the negative direction as was speculated before. And physicists looked at that and they said, you know what, writing Q times S is such a nuisance. So let's come up with a letter for it. Hey, what letter have we used before already? Oh, P. Let's take it one step further. Let's make P a vector. So it looks a lot like the same symbol we used for momentum, but it means something completely different now.
No.
So they decided that they create a vector here that goes from the negative charge to the positive charge. And they called it the electric dipole moment. And so my electric field is, well, I've got 2 KE over R cubed, 2 KE over R cubed, in the same direction as the electric dipole moment. Now, the significance of this formula is not as earth-shattering as Coulomb's law or as basic as the definition of an electric field or the formula for an electric field. The main reason of doing it is in order to just explore just some of the math again, shake some of the cobwebs off. And electric dipole moment does pop up every once in a while. It's nice to have some familiarity, at least with the vocabulary, if nothing else. And also illustrating that physicists, well, one, electric field they just sometimes make stuff up, throw it up against the wall, and that which turns out to be true makes it into the textbooks, or continues in the textbooks. And but there's a whole lot of physics that just ends up in the dustbin of history. I had a friend in graduate school who was working on his PhD. If I told the story already, I apologize. And he said he ended up doing the second topic. This first topic didn't work for him. He said, no one told me when I first started this that this was a 1% chance of a Nobel Prize and 99% chance that it was pure crap. So there's a whole lot of the second that shows up in physics. Hopefully by the time he makes it to the textbooks, some of that's gotten sifted out. But I have some textbooks with wrong information in them if you go back far enough. And we'll address that. Hopefully I'll remember to bring the books in and read you those choice passages of things that were thought to be true, which we no longer believe. So anyway, there it is.
Could you clarify where the negative sign went?
The direction of the electric field is the same direction as the electric dipole moment. The electric dipole moment's already in the negative direction. We established the electric field's going this way. That's the same direction as this.
I see.
So that's where it went.
Thank you.
Just on a quiz or test, if you happen to see this formula, just please remember that is not momentum, because we've run out of letters.
Yes, you can't make up letters, that's not a thing.
Say it again?
You can't just make up random shapes as letters, or?
I've wondered that, and I think if you look at some of the Greek letters that are used, they look made up.
Yeah.
Occasionally you will see in math class, there's a multiplication that goes on with matrices, but they put a circle around it to give it a different meaning. And so there is some of that, or I have an I and a J, but you put a hat on it, suddenly it comes to a different thing. They just haven't opted to do that in this case. I'm sure there's some professor who needed to publish and did it, and it never caught on.
Well, the hashtag is still.
The hashtag P. Maybe. Or in science, it would be called the pound P.
Question, in the formula that you just gave us, is the R is cubed? Is that what that is?
Yes, it is cubed, because we had R squared here, and then after the ones canceled out, we had an S over R, so we had an additional one.
Thank you.
One other comment, that doesn't need to be recorded.